Hey, what's up, guys? Chung here. Uh, so today let's talk about this another lead code problem, number 312, burst balloons. This is like another I think classic DP problem, dynamic programming. So let's take a look. You're given like a array of balloons, and each balloon has a value on it, and you can burst any balloons. So every time when you burst a balloon, you get coins. So the way you get coins is uh, the left of the balloon you bursted times the current balloon's value and times the right side's value, right? So basically, if you burst, for example, if you burst one, you get coins, right? What's the coin? Left times current times right. And after bursting a balloon, those basically this balloon will be removed and this array will become 3, 5, and 8. Right? And then you can choose any of them to burst. Let's say, for example, we burst 5, right? And then we get 3 times 5 times 8, right? And then we'll be adding like two boundary balloons at each end. Basically, why? Because when we burst the last balloon, there's no left and right, right? But we still want to get some coins, right? Based on the coin, the balloon itself. So that's why we need a one on each side. And in the end, we got a total. And then you need to write a program to get the maximum. Basically, you need to find a way uh, about how to burst, what sequence in what sequence we should burst these balloons so that we can have the most coins out of it, right? So, uh, so what should we do, right? I mean, I think first, right? So we need to do uh, uh, write a DP function, DP formula, right? Or DP function, whatever you want to call it. Basically, let's assume we have a DP I and J, right? So what does DPIJ means? DPIJ means equals to from I and J, from balloon, right? From balloon, from I to J. Yeah, let's see burst, right? Burst from I to J, maximum coins, right? So DPIJ means if we burst the balloons from I to J, no matter how we burst it, the maximum coins we can get will be that value in the DPIJ, right? And then the problem comes down, how can we calculate DPIJ, right? And let's say we have a DPIJ is 3156, right? I mean, we can loop through. Basically, we need to try each of the possibilities here, right? Let's say we burst 3, 5, 1, and 5 and 8, and then we get the maximum from all the possibilities, right? But will that solution work, right? No. Why? Because if k, let's say we have a k, right? Let's say k stands for uh we burst number k uh case index balloon first, right? Let's say we burst that one first, and then but the problem is that once we burst that thing, the structure of this array got changed, right? Now the neighbors of 3 becomes to 5, right? It's not 1. So if we just keep bursting, choosing the k to be the first one to burst, and then there's no way we can track the neighbors basically, right? The values will the neighbors of 3 and 5 they all got changed. So how can we solve this problem, right? Instead of using k to be the first one to burst, we can use k. We should use k to indicate the last balloon to burst, right? So how does that work? Then let's say we have I and J, right? Balloon I and and j, right? So we have a balloon and from I to j. Let's say we choose k, right? Let's say we have a k right in the middle here. So k is the one the last to burst, right? To burst, right? If k is the last of burst, basically when k was burst, the balloon from I to j, they were all bursted until except for k, right? Then what's the value of this of the k when the k got burst, right? It's gonna be nums, right? So first, right? So first is the value k itself, right? And then what? And then we need to times the left side, because remember at this moment I and j they're all gone, right? Until except for k. So it's gonna be I minus one here, right? And j plus one, right? So then when we burst k, the coins we get by bursting k will be the num nums k times nums, right? What? I minus one, right? And times nums j plus one, right? That's the coins we get by bursting k at in the end, right? Okay. And then what? And then okay, so that's the bursting of k, right? And then once we have k here, then we have the left and right side, right? Then what's the left side? The left side is the dp what? I sorry. The left side is it means by bursting everything, right? From I to k minus one, right? K minus one, right? That's the dp. That's the value, the maximum coins we can get from the left side. Remember, the dp means the burst from I to j maximum. We get the maximum coins, right? So on the left side is that. How about the right side? dp k plus one plus one to j, right? So that's the left side of the k, the maximum coins we can get from the left side of k, and then that's the coins we can get from the right side of k, right? And then in the end, we just summarize these three, this one, two, and three. Basically, one plus two plus three. That will be the final answer, right? And that's for the answer of k. And for k, we need to loop through I to j, right? With I to j, we need to pick all the possibilities of the k, then we get the maximum out from all of them. And then in the end, we'll be having a dp, right? dp what? I think it's a 0 to n minus 1, right? 0 to n minus 1 means from 0 to the last one. That's our that's our that's the value basically bursting all the balloons from the first one to the last one. Then what's the value of that? Right? Okay, so with this like formula of dp 1 plus 2 plus 3, let's try to code this problem. Okay, so first let's add these two boundary numbers to the array first, right? Because we need those two boundary arrays for us to get our dp's and our in our calculation. We need those numbers for us. Let's see. So that's gonna be numbers, right? So we just add one more and class, right? Numbers plus one, right? That's how we add those two boundaries. and then we're gonna have an n gonna have now we have a numbers here, right? And then we're gonna create our 2D array dp. At the beginning, the coins that are initialized to be 0, and n for in range n, right? So now, since we already have this 1 and 1, right? We have this 1, 3, 1, 5, 8, and 1, right? But we only want to loop all these numbers, right? For the first one, last one, we ignore it because we don't want to pop those things, right? That's how I'll keep it here, right? That's why we have this like this is the 0, right? So now this is the 0, right? And this is the minus 1, right? I'll put those this diagram here so you can see it better. And so since we're doing the from I to J, so I will be tra traversing from the bottom, right? From the right side, so I can do a I equals to J. Otherwise, I need to do a DJJ DPJI. Since I want to do a DPIJ, so I'm gonna do a for I in range, right? So basically we'll be moving from right to the left. That's our first I, right? That's our starting point basically. So what's going to be the first starting point? It's going to be 8, right? So what's the 8? N minus 2, right? And then we're going to, since we're do a reverse traverse, so it's going to be N minus 2 to, the step is minus 1, but we don't stop at minus 1, we stop from 0, right? Because we want to stop at 3, not 1, right? If we put a minus 1 here, we're going to stop from 1, but in this case, we want to stop from 3, which will be 0, right? How about the j here, right? The j is the from I, right? First is from I, and how about the end? The end is n minus 1, right? So because that's the exclusive, so basically it will stop from here. That's the end. That's our end, right? And then we will have a third for loop for k, right? So what is a k? K for k in range what I to j plus 1, right? Basically that's all the possibles. Basically we'll pop through, try to burst, try all the possibilities from I to j, right? We try k to be burst at the last, right? And then we have a dpij here, right? Ij equals to what we have max, right? Because since we're doing the every time we do a max, since we try all the possibilities from I to j, so ij, what's the second one? Second one is first we burst j the last, right? So what's the value gonna be? That's the okay, that's the nums, right? It bursts k at the last, right? And then uh, it's just k or k minus 1 when it comes to number here. So I think this is the 0 to n minus 1. Let me think. Yeah, I think it should be okay because at this moment, since the numbers, we already changed the numbers values now. So right now, this is a number here. This is a number with two more elements here. So at this moment, the k means the correct numbers we need here, right? So k equals, and then what, I minus 1, right? That's the left one after we bursting all the balloons from I to J, right? When we burst the last one, the K times what? Nums, right? J, sorry, J plus one, right? So that's the coins we get by bursting the last K, and then we need to get the left side, right? That's gonna be the left side of K. That's gonna be the dp from I to K minus one, right? Plus what? Plus dp the right side. That's gonna be K plus one uh, J, right? And in the end, we return what? We return the values from here to here, right? That's gonna be returned from dp 1 to n minus 2, right? So that's the range we want, right? That's our actual range. Let's run it. Right. Cool. Yeah, finally works. All right. Okay. So yeah, so I think the concept, the key idea in this problem is that every time we have I and j here, right? We have I and j, we get the we get k. We try each possible positions of k in the range of I and j, and the k means the last balloon to burst, and then the last when we so then when we burst the last balloon, the coins we get will be the current values, right, times the left out of I, because at this moment both I and j they were all bursted. Left of I and the right of j, plus the left side max coins plus the right side of the max coin, and then which for each of the k we keep track of the maximum value out of them, and in the end we just return this. Uh, cool. I think all right. I think that's it for this problem. All right. Thank you so much for watching the video, and okay, I'll be seeing you guys soon.